Hey yo, welcome to Pure 2 Chapter 10.2, where we are going to do iteration, something you've done GCSE, but get your calculator ready because surely you'll be using a lot of the calculator in this lesson. Right, so iteration. So last lesson in 10.1, we looked into sign change method, right? So sign change method help us to approximate the location of the roots, but unable to work out the exact root. So we can sort of know if we do f of something, a value, so f of, let's say from 10.1, if we know f of alpha is a positive number, f of beta is a negative number, what we know is there's a root in between alpha and beta, but we don't know exactly what the root is. Okay, we can't approximate. However, iteration can help us to approximate the actual root. That means the actual solution. So to solve an equation to the form of f of x equals 0, we should, we should rearrange f of x equals 0 into the form of x equal g of x and use it to iterate. Okay, so I'll show you what it means in practical terms. Each iteration could either be convergent, converging, or diverging. The two scenarios for converging iteration, we're not interested in the diverging, which is interested in converging, just like the series, sum to series. Remember in Pure 2, Chapter 3, about sum to infinity series, it's all about converging, okay? Because only converging has something, is something meaningful for us to work towards. Um, the two scenarios. The first one is called a staircase. The next one is called a cobweb. Is it cobweb or cobweb? Give me a sec. No, it's right. It's a cobweb. Cobweb, like a spider, the spider thing. Yep. Right. Let's have a look. Okay. Let's deep dive into each illustration one by one. The first one, staircase. Okay. F of x equals x squared minus x minus one can be rearranged to produce the iterative formula x of m plus one equals square root x of m plus one. We'll look into how these equations can be derived later on. Okay. When f of x equals 0. So let x0 equals 0.5. Now, if you forgot how iteration works, iteration, this means the next term, and x of n means the previous term. So iteration means you can find the next term based on the previous term. Okay, so get your calculator ready because I'm going to teach you how we can use the calculator to generate numbers quicker rather than put it one by one. So first of all, what we do here is, okay, so we'll put 0.5, okay, in the calculator and press equal. So what we're trying to do in here is we're trying to store this value into the answer button. So this answer button now equals to the value which is put in 0.5. And what we do now is, okay, to find the next term, we can put the square root. Okay, now instead of using xn, we use the answer button plus 1. So what it means, if we press equal now, the answer is 0.5, that's x0. So if you press equal, you get, we try to use decimal in here, 1.2247. So x1 equals 1.2247. Now the best thing for this is that if you press equal again, then you generate the next number. So you don't have to keep replacing, you don't have to substitute the previous number, you have to type the previous number into calculate each time. One is time consuming, and two, if you don't put enough decimal places in there, it's not accurate enough. So it's 1.4915, 4916, 1.4916. We'll do a few of them, okay, until maybe x from x4. 1.5785, 1.5785, and then the last one, 1.6058, 1.6058. Now, what we can tell in what we can, so there's a quicker way to do iteration, which we're going to use it later again. Okay, so what we can see in here is from x.5, from x equals x naught equals 0.5 to x1 to 1.2247, you can see the difference here is you're adding around 0.7 ish. From this one to this one, you're adding 0.27 ish. And this one you're adding from here, I think, let me use my calculator. 1.57 minus 1.49, that's 0.08. And this one you can see 0.03-ish. So what do we notice about the gap? The gap is smaller. The gap is getting smaller. So if you look at the staircase, which makes sense, you can see there's the gap number one, gap number 2, gap number 3, gap number 4 is getting smaller and smaller. So where's the solution? Here's the solution. This is the root or the solution. Okay, so that's how we can find the root using iteration. We're getting smaller and smaller. Now, if you press equal, okay, if you use that calculator, press that, keep pressing equal, keep pressing equal, you'll see less and less digit change, and you as you press equal again, it doesn't change anymore. So actually, the root to this equation, the solution to this equation is around 1.618033989. Now, if we use this value, okay, let's say we use this value, put it back in f of x, you should get a value very close to 0. So if we put it back to f of x, so I'm going to use this is my answer, right? So I'm going to answer squared minus answer minus 1. See, you get 0. Therefore, the root essentially is 1.618033989. Obviously, limitation to the scientific calculator. If you use a very, very powerful calculator, I don't know where you can get it from, but you get more and more digits going on and on and on and on. So it gives you more and more accurate result each time, right? So that's that case. What about Cobweb? Okay, let's have a look at this one. Now you see it's the same f of x, same function, but we rearrange it differently. Okay, so now this time, the next term, x of n plus 1 equals 1 over the previous term minus 1 when f of x equals 0. Let x0 equals minus 2. So minus 2. So we'll do that, all right? So why don't we do that? So minus 2, right? Now, but this time, the iteration formula is different. This time it's 1 over the answer minus 1. So that's, yes, there's a minus a third, but let's use decimal in here. Minus 0.333. So x1 equals minus 0.333. Press equal again. Minus 0.75. Press equal again. Minus 5714. Press equal again. Minus 0.6363. 64. Actually 6364. Now what can we see in here? Okay, now let's work out difference again. From minus 2 to minus 0.33333. So we're adding 1.667 in here. From negative 0.333, now we are actually the number. So you see this number is negative 2 and negative 0.33. So we're increasing, but from 0.33 we're decreasing again from 0.75, but which is to 0.417. So this time we're subtracting 0.417, and then from 0.5714, from 0.75 to 0.714, which is we're going positive. So we're adding 0.179. The decimal is actually getting bigger, getting smaller again. So from here, from negative 0.5 to negative 0.6, you're getting smaller again, 0.09 roughly. Okay, is it 9? No, 6. Okay, so what can we tell? First of all, if we ignore the sign, okay, if we ignore this, so there are two things we can see in here. If we ignore the sign, we can see the gap is smaller again. You can see it. Just look at the raw value, 1.67, 0.417, 0.179, 0.06. All right, next, but also the sign. So we're going plus, minus, like a Cobweb. You can see in here. First of all, down, up, down, it doesn't matter. Yeah, x1, sorry. It's down, up, down, up, down, up. So down, up, down, up. But also you can see the lines, the length of the lines getting smaller and smaller. So we are sort of like spiraling to a value. Now again, if you press equal, keep pressing equal, keep pressing equal. Okay, you see it's the same value as we did last time, 0.6, negative 0.618. And that's a Cobweb. That's a Cobweb. The question in the exam, they could ask you which type of converging series it is, a converging iteration is this. Is it Cobweb or a staircase? They'll ask you to draw a diagram. It has happened in the past paper before. Okay, right. Last one, diverging, which is the one that we don't really look at. The reason being is that if you try putting a calculator x0 in here, so they rearrange it into a different way again, xn squared minus 1. So this time, when x is 0, put 0 in the calculator, Okay, and then put answer squared plus 1, minus 1, sorry. Minus 1, 0. Oh, did I put in the wrong number? Oh, sorry. Answer is 2. Sorry, hang on. Let's do it again. 2. Sorry. X0 is 2. 2, let's start again. Answer squared minus 1. 3, 8, 63, 3,000, 150, blah, 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 blah. Maths error. Okay, so you can see the number is getting bigger and bigger and bigger. So you can write in here. What's x1 again? I can't remember now. Was it 3, x2 was 8, x3 was 63. So it's diverging. The gap is increasing. The gap is increasing. That's how you know it's a diverging iteration. So, and this not useful. So not useful for approximating the roots. That's what we're trying to avoid, divergent. Okay, because you can see going up and down. Bye-bye. Where's the root? The root actually is here. That's the root. Okay, so actually when we start with x0, we realize we've gone away further and further away from the root. Bye-bye. And this one, by the way, this is the root. Okay, this is the root. Okay. Right, so after those sort of theoretical stuff, let's do the real stuff. Okay, the real maths. F of x equals x squared minus 4x plus 1. Show that equation can be written as x equals 4 minus 1 minus x. Now, so what they've done in here is they have converted, so they have make this into, so change, they make x a subject. So then it becomes x equals 4 minus 1 over x, sort of. But now you can see there are two x, isn't it? So you're wondering which x did they make a subject. So this is what I suggest. I suggest you, by the way, this doesn't exist typo. I suggest you to work backwards. I suggest work backwards. Okay, so jottings. Okay, so jottings. Now, that's not something you should write showing exams. So these carry no marks, but it help us to work out which x they're talking about. So in here, what we're doing is we'll try and make it back into f of x equals 0. So from the answer, we'll work backwards, times everything by x, and then bring everything left inside. Okay, so the actual solution. So the actual answer. Actual working. So all we can do is we'll start from x squared minus 4x plus 1 equals 0. Essentially, we'll just copy the step backwards in here. So x squared equals 4x plus 1 divided by x. Did I make a mistake in here? Or a minus 1. Okay, and that's it. That's the answer. Okay, right. So if you remember about year 1, there's about a proof by deduction. I think, yes, that's also something, jottings and work backwards from the answer and then you write the actual working out again. So given f of x has a root alpha in the interval 3 and 4, and b, okay, so we're given this iteration formula, x of n plus 1 equals 4 minus 1 over xn, this where it come from, with x0 equals 3, find the value of x1, x2, and x3. We've done this actually in the previous sort of illustration. So if you want to possibly have and work out x1, x2, x3 using a calculator, be my guest, have a go. But otherwise, this is what we'll go through. So I'm just rewriting f x of n plus 1 equals 4 minus 1 over xn. So x0 is 3. So this is what I do, okay? So this is what I do. I will be doing 3 and an equal, and then 4 minus 1 over, replace xn as answer button. So 11 over 3 or 3.67 doesn't matter because we're not really looking into the investigation of numbers. So you can put either a fraction decimal, 11 over 3. Next one. Or actually, let's put decimal in here, 3.67. Next one. Press equal again. 3.727. Next one. 3.73. Did they say given which accuracy? No. Okay, that's fine. Usually it will tell you 5 decimal place, 4 decimal place. 3.7317. 3.7317. So maybe you can tell me, okay, is it a stair, is it convergent? First of all, is it convergent? Okay, this question is not asking you, okay, but just for you, is it convergent or diverging? Is a converging because you can see the gap is getting smaller from smaller. So 3 to 3.67 is around zero point 0.6. From here it's zero point 0.1 and that's zero point 0.01. So it's getting smaller and smaller. Okay, so it's getting smaller and smaller. The value, the gap is closing, so it's converging. So next question, is it a staircase or is it a cobweb? Now, consistently, we're adding a number each time, zero point 0.6. So we're adding zero point 0.1 around, that's zero point 0.01. So we're adding a number each time to a staircase. Okay, a cobweb will mean we are fluctuating numbers. The gap will be adding and then subtracting, adding, subtracting. So like a spider, back and forth. Uh, like in a dining room, living room, when you see a spider in the corner, you do a bit of dancing with spider because you're too scared to go to the spider and smash it. A legend would say use a fire, set fire to the spider and set the house on fire because the spider living there. Well, that's what people do, but I don't. Right, because I'm logical and I have a mortgage to pay for. Example, given f of x equals x cubed minus 3x squared minus 2x plus 5. So the equation has a root between 3 and 4. So this way you have to use the sign change method. So f of 3. Okay, so f of 3 equals 3 cubed minus 3 times 3 squared times 2 times 3 plus 5. So you put in the calculator, you should get minus 1. If you put f of 4, you should get 13. So you will say sign changes. There's a root between 3 and 4. Okay, so sign change method in 10.1, which we covered in last lesson. So probably use the iterative formula, okay, to calculate x1, x2, x3. Give your answer and to do 4 decimal places, taking x0 equals 1.5 and next one x0 equals 4. So why do we do that? So B1, okay, so x0 equals 1.5. So I'm not going to show it on the screen. I'm just going to do it on my calculator. So we should be doing 1.5 and an equal, and then put a square root, a fraction, answer cubed minus 2 answer plus 5 over 3. Actually, you know what? I'll just put in there just in case. So you should put 1.5 equal, and I'll do fraction answer cubed minus 2 times answer plus 5 over 3. And you get 1.3385. They're only 4 decimal places, so be careful with the question. Okay, make sure you round it as well and press equal again. X2 equals 1.2545 and X3 equals to 1.2200. Okay, question for you again. Okay, is it converging or diverging? Is it a staircase or cobweb? Well, is it converging because you can see a gap is getting smaller and smaller, the number is getting closer and closer to a certain value. It's a staircase because they are consistently subtracting by a number. We're not adding, subtracting, we're consistently subtracting number. Okay, so or the number is consistently getting smaller and smaller. Okay, B2, okay, do the same. So x0 equals 4. So let's start fresh. So 4 equal. Again, and then you should get x1 equals to 4.5092, x2 equals to 5.4058, and then x3 being 7.1219. So this time is a, by the way, for the so it's a converging, previous converging staircase. This one is a diverging, okay, because the number is getting bigger and bigger. Right. So practice, pause the video, really have a go at the question. When you're ready for the answer, you can press play. That's the answer to part A. Okay, you show your jottings, you show working, you don't have to show your jottings, that's why I cross it out. Okay, just for my working out, and then these are the final answer. You just write your step backwards. Okay, and then now I'm going to do part B. And here are the answers. Okay, very straightforwardly. Yeah. Okay, and one more exam practice. Pause the video, have a go at the question. When you're ready for the answer, you can press play. Here's the answer for part A. The jottings, essentially just making rearranging from the answer back to the original, and then do the working out. Okay, actually, I should cross out the jottings. Okay, next, then part B, using the iteration, you can easily put in a calculator. Remember, put 2 in the calculator, press equal, and then replace xn with answer. So you should be using ln, bracket 6 minus answer, bracket plus 1. And then keep smashing the equal button. Just be one thing to be mindful of, which is 4 decimal places. So make sure you write your answer in 4 decimal places and round it correctly. Okay, I see students not rounding it, some rookie mistake, but you have to round your numbers. Question C, if you've done in your 10.1 exercise, you realize this is the same question, but there's a sign change. They do not tell you sign change, but you need to know it's a sign change question. All right, and that's the end, I believe, for 10.2.